Hello, everybody. My name is Uday Narayanan, and I am a solutions architect at AWS. And I'd like to welcome you all to this webinar where we'll talk about breaking down data silos and analyze across all your data with Amazon Redshift data sharing. During this session, we'll do a quick overview of Amazon Redshift and talk about some of the new features of Redshift. We'll then talk about Redshift data sharing, followed by AWS Data Exchange for Amazon Redshift. We'll then discuss some use cases for data sharing and steps to set it up. We'll then see a quick demo of how to set up data sharing with Amazon Redshift and the experience from the provider and the consumer side. We'll then wrap it up with next steps. With that said, let's get started. Amazon Redshift is the most widely used cloud data warehouse, and it is helping tens of thousands of customers manage analytics at scale. With Amazon Redshift, you can analyze all your data, enable different types of users and personas, and get to performance at any scale with low and predictable costs. Based on the feedback that we have received from customers, we are focused on three key investment themes for Redshift. The first one is easy analytics for everyone. So as the number of personas are growing, not everyone has the experience with data warehouses. Redshift's goal is to provide an easy getting started experience where customers can get insights quickly so they can focus on their business outcomes rather than worrying about managing their data warehouse and provisioning infrastructure. Setting up a Redshift cluster is easy and can be done in a few clicks. Amazon Redshift is compatible with many BI tools, opening up the power and integration of Redshift to business users who usually operate from within the BI tool. The second theme is to enable customers to analyze all of their data. As customers are moving towards a modern data strategy with Redshift as their data warehouse, S3 as their data lake, and using purpose-built data stores, being able to analyze the data, irrespective of where it is stored, is becoming more and more important. And the third theme is around price performance at scale. Redshift provides the best price performance at any scale. With RA3 nodes coupled with managed storage, Redshift provides up to 3 times better price performance compared to other cloud data warehouses. Redshift RA3 nodes with managed storage separates compute and storage, so you can scale each independently and only pay for the storage that you need. Redshift is a self-tuning and a self-learning system that allows you to get the best price performance for your workloads without having to deal with the undifferentiated heavy lifting of tuning your data warehouse with tasks such as defining a sort key, distribution key, running vacuum commands, and so on. So now let's dive into our investment area for analyzing all your data. Redshift's strong integration with other AWS services has enabled customers to combine Redshift data with other data stores without leaving your data warehouse. This reduces the need to build additional ETL pipelines that may take days or even weeks to build. And there are 4 key trends here that I'll talk about. The first one is, as customers are storing their data in their data lakes in S3, they're using Redshift Spectrum to bring the data from the data warehouse and the data lakes together to build powerful analytics. Redshift Spectrum also integrates with AWS Lake Formation, so you can provide fine-grained access control for your data. In addition, you can unload your Redshift data into the S3 data lake using the data lake export feature. This data can then be analyzed using other popular analytics services such as Amazon Athena, EMR, as well as machine learning services such as SageMaker or other AWS AI services. Next is customers are looking to share data across clusters and organizations. With Redshift data sharing, we made it easy for customers to share data across multiple clusters. We also introduced the integration of data sharing with AWS Data Exchange, where third-party providers can make their data available in Redshift delivery format, and consumers can directly access that data from their Redshift cluster. As more customers are leveraging the data within their organization to get faster insights, they want to have the ability to query data in place without moving data. Think of a scenario where you have a data warehouse in Redshift and some operational data stored in RDS MySQL or RDS Postgres or Aurora. With Redshift federated queries, you can query your relational data stores in RDS Postgres or MySQL or Amazon Aurora seamlessly and join that data with the data in Redshift data warehouse. And all of this can be done in place without having to move the data. An example of this would be doing a customer 360 analysis to understand customer behavior across multiple data stores. Finally, as many customers are looking to run machine learning inferences using Redshift data, we have introduced a feature called Redshift ML to make it easy for SQL developers to run machine learning workloads in Redshift. You can simply use SQL commands to create and train machine learning models using your Redshift data, and then use these models to make predictions. And as mentioned earlier, all of this can be done by just running simple SQL statements. Now, for the rest of this talk, we will be focusing on the data sharing feature of Redshift, its advantages and use cases. But before talking about Redshift data sharing, let's look at how customers used to share data between clusters before this feature was available and the challenges that they faced. Many customers who use Redshift have multi-cluster deployments. In order to share data between clusters, customers have to manually unload the data and copy the data from one cluster to the other. The producer cluster is where you want to copy the data from, and the consumer cluster is where you want to copy the data to. Now, on the producer side, this process to manually unload and copy the data can become cumbersome and expensive, especially as the number of clusters grow. You will need to build and maintain ETL pipelines to share the relevant subsets of data to each consumer. You also need to incorporate security and governance into this to make sure the consumers are only getting access to the data that they need and nothing more. There are challenges on the consumer side as well, because you need to reconstruct the data that is coming from the producer clusters. You need to manage the schema changes. There are also challenges with stale data because the ETL job is not running continuously. This results in consumer clusters being refreshed only a few times a day when the ETL jobs run. So you cannot provide real-time insights to the business. Then there's also a concern around incomplete or inconsistent views of the data, which can again limit insights for the business. This process also introduces data silos, and business can lose trust on the data because of inconsistent data. So Redshift data sharing solves these challenges. Data sharing was launched as a simple and a secure way to share live data across multiple Redshift clusters. So this allows customers to access live data in a transactionally consistent fashion without having to deal with ETL processing or data copies. The owner of the producer cluster has the flexibility to share the data at either a database level, schema level, table view, or a SQL user-defined function level. The consumer cluster gets immediate access to the data. There are no delays. This means as and when there is an update in the producer cluster, the consumer cluster is getting immediate access to the data, and the data is transactionally consistent. So, when you query, when a query is run on the consumer cluster, you will see the data, or you will see the latest data. Data sharing also provides a secure and governed collaboration. You can share the data within your organization or with your external customers or partners. The producer cluster will always maintain control on the dataset. At any point, if access is revoked for a consumer cluster, the consumer immediately loses access to that data. With Redshift data sharing, you can share data between Redshift clusters within the same AWS account, across multiple AWS accounts, or across multiple AWS regions. So we have many customers leveraging the data sharing features and data sharing capabilities of Redshift. A few of them have been listed on the slide here. Let's talk about one of the customers and how they're using data sharing. So in this case, we'll talk about Warner Brothers. Before data sharing was available, Warner Brothers had to build and maintain complex data mobility infrastructures to manage data movements between their individual Redshift clusters and the consolidated business function clusters. However, developing and maintaining this process introduced delays that impeded their ability to act on the data with agility and speed. Using the Redshift data sharing feature, they can remove the entire subsystem that was built for data copying and loading between different Redshift clusters. This also helps their business teams to make decisions more quickly and efficiently. All right, so now let's take a quick look at how Redshift data sharing works at a high level. So data sharing builds on Amazon Redshift RA3 nodes and Redshift managed storage. RA3 is the next generation instance type, which allows you to separate compute and storage. With these node types, you can scale your storage independently of your compute. Now, in this picture, you can see we have a producer cluster on the left, which is sharing some objects with the consumer cluster on the right. The data is stored in the Redshift managed storage layer. When the consumer cluster is running queries on the shared object, the compute from the consumer cluster is being used, but the whole data access is happening through the managed storage layer, so there is no impact on the producer cluster. The producer and consumer clusters are regular Redshift clusters. So the consumer cluster has read-only access to the objects shared by the producer cluster, but at the same time, the consumer cluster can have its own private data that it can read and write to. From a cost perspective, the producer pays for the managed storage and the consumer pays for the consumer cluster. Data sharing does not have any cost associated with it. With AWS Data Exchange for Redshift, you can find, subscribe to, and query third-party data in minutes. But first, let's take a step back and talk about what is AWS Data Exchange. AWS Data Exchange is a marketplace connecting organizations looking to use third-party data with organizations looking to license their data. We refer to the organizations looking to use the third-party data as data subscribers, and the organizations looking to license their data as data providers. AWS Data Exchange provides one place to exchange data publicly or privately, allows you to easily manage your subscriptions, and automates the billing and payment process. You can see a summarized diagram of how AWS Data Exchange for Amazon Redshift works on the slide here. The provider stores the data in their Amazon Redshift cluster. Subscribers will subscribe to the data via the AWS Data Exchange service. Once the subscription is approved, the subscribers are able to query the provider data from their own Redshift cluster. The subscriber is able to access the data for as long as the subscription is active. Once the subscription expires, they are denied access to the data, and all of this happens automatically. Note that AWS Data Exchange integrates with AWS Marketplace to automate payments and billing to simplify the licensing process. The data sharing feature of Redshift is the foundational capability that enables AWS Data Exchange integration with Amazon Redshift. And we have many customers leveraging this feature as well, a few of whom have been listed on the slide here. So how does AWS Data Exchange for Amazon Redshift help data subscribers? First, it gives subscribers the ability to query and analyze third-party data that they have subscribed to within a matter of minutes. They don't need to deal with doing complex ETL processing because the data can be accessed directly from the provider. So there's also no lag because live data is available to the subscribers. So there is no need to download the data from the provider and copy it into your own Redshift cluster. It also helps to manage all third-party data subscriptions in a single place. From a data provider perspective, they get a simple and convenient licensing experience. They also don't need to do any complex ETL processing. They can offer multiple delivery methods in a single product. Today, there are 3 delivery methods supported by AWS Data Exchange, which are S3-based, Redshift-based, and API-based. And automatic entitlement, bill, and payment management makes their life a lot easier from a billing perspective as well. Right. So now let's look at a few use cases where Redshift data sharing can be used and can be beneficial. So first use case we'll look at is what I call cross-group collaboration. Many organizations want to decentralize the management of their data warehouse instead of having a large data warehouse for all the teams. With this approach, each team will maintain their own Redshift cluster. Each cluster can act as a producer for other clusters, as well as consume from other clusters, forming a mesh type of architecture. A use case of this could be that the organization wants to do a cross-product impact analysis as part of some campaign that they're running, which requires them to use the data from the different departments' Redshift cluster. Another advantage of such an architecture is because each department has their own Redshift cluster, you can build a chargeback process where the business unit or the product team can be charged for their own usage of Redshift. Let's take Fannie Mae, for example. Fannie Mae adopted a decentralized approach to data warehouse management with tens of Amazon Redshift clusters across many applications. While each team manages their own data set, they often have use cases where an application needs to query the data set from other applications and join with the data available locally. Before data sharing, they would unload and move data from one cluster to the other cluster, and this introduced delays in providing timely access to data to their teams. Data sharing allows Fannie Mae to skip this intermediate unload to Amazon S3 and hence save time and reduce complexity. With data sharing, they are able to enable seamless sharing of data across application teams and give them common views of data without having to do any ETL. Another use case is around workload isolation, where you need to support very diverse business-critical workloads easily and cost-effectively while still meeting the SLA requirements. With data sharing, you can rapidly onboard new analytics workloads. So think of a scenario where a developer reaches out to their data warehouse administrator saying they want to do some ad hoc analysis for the sales data in the production Redshift cluster. The administrator can tell the developer to spin up their Redshift cluster and share the data the developer needs with that cluster that was spun up. This way, they will need, or the developer will get a read-only access to the data within minutes of requesting it. So the consumer does not need to worry about where the data is coming from or do any kind of ETL processing. With this approach, we are also preventing the creation of data silos because data still resides in the Redshift managed storage layer. And it makes it very easy to support ad hoc workloads with this type of use case. The second aspect of workload isolation is you can size and scale individual workloads according to the performance requirements. So as you can see in the picture or in the slide here, we have an ETL cluster, a dashboard cluster, and a data science cluster. Depending on the performance needs, all of these clusters can be sized differently and can have different node types and number of nodes. Finally, you can pause and resume clusters as needed as well. So let's say the ad hoc query cluster is only being used for a few hours in a day. You can pause the cluster during the times it is not being used and save cost. Another very common use case is delivering data as a service. This becomes very relevant with cross-account data sharing. The idea is you are managing the data centrally as an asset, and you are sharing the data with consumers that could be in the same organization or in a separate organization, such as your customers or partners. Data sharing makes it very easy to provide data as a service because you don't need to move the data. You can securely share live data with consumers in the same or different AWS accounts or same or different AWS regions. With data sharing, you can also monitor and track usage of the data and understand if the data is useful for your customers. And as discussed earlier, the provider will retain control of the data sets. For a consumer, you don't need to worry about transforming the data and copying the data into your Redshift cluster. You can directly access the data as a consumer without having to worry about complex ETL processing. And the final use case we'll talk about is around sharing data between environments. So usually in companies, you will have a development, test, and production environment. Without data sharing, you would usually take a Redshift snapshot from your source cluster and restore it in your target cluster. One scenario where this approach is useful is when there is an issue in the production environment that the development team needs to be able to reproduce and debug. The development team can get access to the relevant data from the production cluster via data sharing, and then they can use that data to do their debugging and get to a resolution faster. This improves agility as well. Now let's talk about Stripe and how they used Redshift data sharing capability to build the Stripe data pipeline. Companies of all sizes use Stripe's software and APIs to accept payments, send payouts, and manage their businesses online. Stripe Data Pipeline is a tool which customers who store their data on Amazon Redshift can benefit from. So what challenge does Stripe solve with the solution? Before the solution was launched, customers who wanted to analyze their data in their data warehouses could build an API integration to export the data, which could take multiple months, right? So export the data from Stripe. The other alternative would be to build ETL pipelines, which again has its own challenges. Now, both these options introduce data latency and inaccuracy. With data pipeline, Stripe enables their customers to set up a direct and reliable pipeline in mere minutes and be able to access their data in real time. Stripe Data Pipeline is powered by Amazon Redshift's latest RA3 instances, which provides cross-account data sharing capabilities. So some of the benefits provided by the solution are, it's scalable and it's a managed data pipeline. So customers don't need to build custom ETL jobs to ingest the data. It provides up-to-date financial data. So customers have access to up-to-date data because they are not extracting data in batches, but instead querying the data in real time. It's secure and provides compliance. So data is shared directly from Stripe with customers' Amazon Redshift cluster. So the confidentiality of the data is protected in rest as well as in transit. And then this solution is extensible as well. So once the data is accessible in AWS, you can leverage the breadth of native integrations with other services that Amazon Redshift supports. Right. So as you can see in the slide here, once the data is shared and it's available in the customer's AWS accounts, they can, if they want to build some kind of reporting on top of it, they can use Amazon QuickSight, or if they want to integrate or join the shared data from Stripe with some data that they have in their relational data stores or data lake, S3 data lake, they can use the Redshift federated query feature to bring all of that data together and do a powerful analytics. Right. So before going to the demo, let's quickly talk about the steps that a producer and a consumer needs to do to make data sharing work. Right. So on the producer side, first step is to create a data share container for sharing the objects. Once the data share is created, the producer will add objects at the desired granularities that they want to share with the consumer. So they'll add the objects into the data share. And then finally, you add the consumers, right? So consumer can be Redshift clustered in the same account or a different account or across AWS regions, but you just add the consumers that you want to share that data share with. On the consumer side, you can list the shares that are available and review the contents of each share. Then you can create a local database and a schema reference to the shared objects. And then finally, grant permissions on the shared database and schemas to the users and groups in the cluster, right? So once the permissions are granted, when the user logs in, that user will be able to see the data, the data shares and run queries on top of it. All right. So now let's quickly go through the demo scenario that we'll be doing the demo for. So our company has a central analytics center of excellence team. This team is responsible for ingesting all the data from different sources, transforming them as needed, and storing them in a central location. Then, depending on the needs of the different teams, the analytics center of excellence makes the data available to the different teams. Also note, not every team needs access to all the data. If in our use case, we have the finance team and the marketing team. The finance team needs access to all the tables, but the marketing team only needs access to a subset of the tables. Prior to Redshift data sharing, the Analytics Center of Excellence team would build ETL pipelines to copy data from the central Redshift cluster to the individual team's Redshift cluster. They have to build an ETL process for each team because the requirements around what tables to copy over and the timing and the frequency of the jobs differ between different teams. Some teams would want the data at 5 in the morning, while other teams might want the data to be refreshed at 8 in the morning. And this all depends on what kind of downstream processing they're doing. And also the frequency of how many times in a day the data needs to be refreshed differs. There's also a challenge of marketing and the finance team always getting a point in time snapshot of the data. This entire process costs time and money and creates data silos and duplicates across multiple clusters, right? So this is the left side of the slide here. Now, moving to the right side, with data sharing, the Center of Excellence team just needs to create 2 data shares, one for the finance and the other for the marketing team. Add objects they want to share with the 2 teams into their respective data shares. And that's it, right? And then the data is available for the marketing team and the finance team to consume. The advantages are the finance and marketing team get access to the live data. It eliminates the complexity of complex ETL processes, and we are not creating data silos anymore. And as discussed earlier in the talk, Redshift data sharing works with clusters in the same AWS account and across AWS accounts and across region. So for this demo, the analytics center of excellence cluster and the marketing cluster are in the same account, but in different regions. But the finance cluster is in a completely different AWS account. All right. So enough talk. Let's jump into the demo, and let me switch to my AWS console here. All right. So currently, I'm in my main account, and as you can see, this account ends in 7398. I'm in the Oregon region, and this is where my analytics center of excellence cluster is. So if I log in to the cluster, and again, you can use any client to connect to the Redshift cluster. I'm just using the Redshift query editor version 2. If I connect to this cluster, I have this orders database, a public schema within it, and I have 8 tables and a view that has already been created, right? So this is my analytics center of excellence cluster. Now, I want to share this, this data with the finance cluster as well as the marketing cluster, right? So let's start with the finance cluster. So as discussed in the slide earlier, the first step is to create a data share, which is a container that will hold all the objects that are being shared with the finance cluster, right? So we'll run this command and we'll create a data share. Now we need to add objects to the data share, right? So we'll run these commands here and then we'll walk through it. So in the first one, we're just adding the public schema, which is the schema here. Then we are adding all the tables in that schema, because as discussed earlier, the finance cluster needs access to all the tables in the analytics COE cluster as well. And then this third line here is to make sure that any new tables or views that are created in the analytics COE cluster, the finance cluster automatically gets access to it, right? So you don't want a new table when it's created, an admin to come in and run these alter commands again. We want the finance cluster to automatically have access to the data. So this third statement does that. All right. So now let's quickly look like what it looks like from a what the data share that we just created looks like. So we have a share name of finance share, which corresponds to this name that we gave it. It is created on the orders database, and if you look at the share type here, it is an outbound share, right? So outbound share meaning I am the one who created the share. It's not something that is being shared with me. It is something that I have created, and then I'll be sharing with my consumers. If you look at the objects that is added into this data share, you'll see there are 10 objects in total, which is like the schema, the 8 tables, and the view, right? So the 8 tables and the view, as you can see here. And let's look at the consumers. Right now, this is not going to return anything because all we have done so far is we have created a data share and added objects to it. We haven't shared it with anyone, right? So the next step here, we will share it with the finance cluster. So if you remember, the finance cluster is in a completely different AWS account. It is not in this same account as the analytics cluster is on. So in order to share it with another AWS account, we're going to run this query where we grant usage on the data share to that account, right? Great. Okay, so that worked. Now let's go to the Redshift console and click on data shares to see what it looks like. So the finance share that we just created, that shows up here. And under the data share status, it says there is some action required. So let's click on this and see what action is required. So it says it's pending authorization. So in the status. So we'll click on this and we'll authorize. And essentially all we are doing here is it's asking, okay, you're going to grant access to this particular account to this data share. Do you really want to do it? And I absolutely want to do it. So I'll say yes. All right, so this is set up. So the producer side of things have been set up. Now I'll switch to my finance cluster. And as you can see, I am in a completely different account. This account ends in 7245. And I have this finance cluster right here. So let's go into the data shares and from other accounts, because this is something that is being shared with me from another account. And the data share status here also says action required. So let's click on this and associate, right? So basically what we're doing here is we are associating the data share that was shared with us from the other account with clusters in our own account, right? So we have two options here. You can do it for an entire AWS account, which pretty much means that all existing and future namespaces across different AWS regions in your AWS account will have access to this data share. In our case, we don't want that to happen. We only want the finance cluster to have access to it. So I'm going to select this one, click on Add Region. My finance cluster is in the Oregon region. So I'll select that, and I'll click on Add Specific Namespaces and select the finance cluster, and then say Add Region. And then at the bottom here, we'll click on Associate. So again, what we did here is that the data share was shared with us with this particular account. We just went in and we associated that data share with the finance cluster. All right, so now we are here. Let's just do a quick refresh. So now if I run this first command, right, again, just to see what data shares are available in this account here. So if I run the first command, you will see that this finance share that was just shared with us is available. And here the share type is inbound, which means this is something that is being shared with us. And let's check out the objects that we have available to us. And it shouldn't be a surprise. All the 10 objects that were shared are available in this account as well. So the schema, the 8 tables, as well as the view. Okay. So now the next step is for us to be able to run queries on this data that has been shared with us. We need to create a local database, right? So we'll create a database called consumer finance, because we're consuming the data from the data shared finance share of account this. So this is the account of the producer or the provider. And then this is the namespace for that cluster on the provider side, right? So I'll just run that query and do a quick refresh here. And we see that it's created. The database is created, the public schema is created, and all of the tables and the view is available for us. The next step is for us to grant usage on the database to local users, right? So you can have different users and groups that have access to this cluster. You can grant them access to this particular database so they can run queries on top of it. So let's just do a quick test to see how this works. And it works fine, right? Or we're able to access this region table, and this is something that was just shared with us by the other account. All right, so now what else can we do? So now let's look at this dev database. And within that database, there is a local schema. And I have created one table here, right? So the difference, as you can see with the sign here as well, this dev database is local to this cluster. The consumer finance database is something that has been shared to us via Redshift data sharing. Now, what we can do is we can actually join the tables in the consumer finance database with the tables in our local database, right? So that's what I'm doing here. So if I'll start with the from clause, I have this consumer finance public orders table. So if I just quickly open this, I have this orders table. So it's a database, schema, and table name. And then I have this local order status table. And I'm just running a query to get the sum of all the sum of the price for the orders depending on the order status. So if I run this query here, we get the results back, right? So we can very seamlessly join a table that has been shared with us from another Redshift cluster and join that with a local table which is present on our own cluster. All right. So now we've satisfied the first requirement from the finance team's perspective. So the finance team has access to all of the data that they need. Any future data or any future tables that are created in the analytics center of excellence cluster will automatically be added to this data share as well. Okay, so now let's move on to our second part of the use case, where we want to grant access to the marketing team to the marketing cluster. Right. So some of the processes are going to be similar. We first create a data share. So in this case, we'll call it the marketing share. And then we'll add objects to that data share. So in this case, we are adding the schema, and we are only adding one table. So instead of adding all of the tables, we are only adding one table, which is a view actually. So the orders marketing is a view. And we only want the marketing team to have access to that one view, nothing else, right? So if we again run this query here just to see the data share and if it's been created, you'll see that the finance share from before is still there. The marketing share is created. Both of these are outbound. And again, both of these have been created on the orders database. Now let's check out the objects. So we have, again, as you can see, the number has increased from 10 to 12. So we have the 10 objects from the finance share, but we also have these 2 for the marketing share as well. So again, the schema is here as well as the view. So as you can see, right, it's exact, the provider or the provider database is the same. And we created 2 different data shares, one for finance, one for marketing. For finance, all the tables and views are being shared. For marketing, only one view is being shared. So, you can very easily control who gets access to what. If we run the consumer, the data share consumers, we only see the finance share because we have not shared this data with the marketing cluster yet, which we will do right now. So again, it's the same command, grant usage, but instead of to an account number, we are actually doing it to a namespace because if you remember, the marketing cluster is in the same account, but in a different AWS region. All right, so that's succeeded. So let's look at the consumer, the data share consumers again. And now you will see that it shows up here as well, right? So now we have created the marketing share, and we have shared it with the marketing cluster, which is in a different region in the same account. So let's switch to that now. Right. So this is my marketing cluster. And again, as I said, it's in the same account here, but it's in a different region. So our analytics cluster was in the Oregon region. This is in the Virginia region. So let's connect to the cluster and just do a quick refresh here. Right. All right, so let's just quickly run to see what data shares are available. So again, the marketing share that was shared with us from the analytics cluster, we see it here. Let's check out what objects are available for us. And we have 2 objects, right? The schema as well as the view, because that's all that has been shared with us. So similar to what we did on the finance side of things, we're going to create a database called consumer marketing, because again, it's a marketing cluster and it's a consumer. And then we're creating it from the data share called marketing share. So I'll just select this and run. And then again, similar to before, we need to grant usage for the users of this particular Redshift cluster. So we'll do that here. Right. So if I quickly do a refresh, my consumer marketing cluster shows up. The schema is here, and I only have access to the view. As you can see, none of the tables are available because, again, that was not shared with me. And then you can easily run queries on top of that data. So here I'm just doing by marketing segment and country, what is the total price of the different orders that we have, right? So everything works, and you saw how easy it was to grant access to a cluster to data using data sharing. Now let's go back to the analytics center of excellence cluster and see what happens if I revoke usage, right? So there's some requirements have changed, and it was decided that okay, marketing team does not need access to the data anymore. So we don't want to keep giving them access to it. So let's revoke the access. Right, so this command succeeded. Now let's go back to the marketing cluster here and just try to rerun this query again, right? Again, I'm in my marketing cluster, rerunning the query that just succeeded, and we get an error. It says, the data share doesn't exist or is not accessible. And that this is because the access was just revoked. So if I go back up here and let's see what objects have been shared with this cluster, and you'll see there's nothing, nothing shows up. Now let's go back to the analytics COE cluster, right? Because maybe it was like a mistake or some kind of a miscommunication, and the access actually should not have been revoked. So somebody comes to the analytics COE team and tells them, hey, we lost access. Can you grant us access? Grant us the access again. And the analytics COE team says, oh, no problem. Just come here. They'll run this query and grant usage. So now the marketing team will go back into their cluster. They'll check to see if the data shares are available. And they'll be like, oh, okay, it's available. It's inbound. Everything looks good. So let me go and run this query again to see what it looks like. And everything is back to normal, right? So it's as simple as that. So instead of running these complex ETL pipelines and processes to do these transformations and maintaining one of these for each of the downstream systems, in this case, we just talked about the finance and the marketing team. But in reality, for a big company, you can have like tens of hundreds of different clusters that need access to this data. So building individual ETL processes can become really cumbersome and take up a lot of valuable time, right? Where the analytics center of excellence team can be doing some other things as well, instead of building these pipelines to copy data from one place to the other. And as we know, if we are copying data from one place to the other and having multiple copies of the data and creating data silos, inadvertently those two data sets will drift apart, and you run a query on one cluster, it gives you one result, and you run a query on the other cluster, it gives you completely different results, which kind of ends up causing loss of trust in the data as well. So creating data silos is definitely not a good idea. So with this kind of approach with Redshift data sharing, it's as simple as creating a data share, adding objects to the data share, and then granting permissions so the other cluster can easily access to the data. We're not creating data silos, and everything works very seamlessly. All right, so let me go back to my presentation and just to wrap it up. Just want to talk about next steps. So if you want to get started with data sharing, you can talk to your AWS account team and set up like a quick demo, and they can walk you through this process of how this all works and help answer any more questions that you might have. If you want to learn more about data sharing, the data sharing features URL here kind of gives you more details on how it all works. If you want to learn more about AWS Data Exchange for Redshift, you can get that information from that URL here. And then there are some demos that are available on YouTube that you can look at. So we didn't go over the data exchange for Redshift demo, but that URL kind of provides you a good overview of how that works. And then we have an Amazon Redshift workshop as well. So if you want to dive deep into these steps that I did and get hands-on experience doing this data sharing or setting up data sharing in your own accounts, the workshop has a step-by-step guide of how to set it up. And again, your account team should be able to help you with that as well. All right. So with that said, I just wanted to thank you all for your time and attending this webinar. Have a great day, everyone. Thank you.